But before I talk more about maps, let me talk about another problem. So lately, because Christmas is coming up, people are ordering a lot more packages, mostly presents for their loved ones. And at some point, this was all fine, but people are not always at home, of course. So the delivery person sometimes goes to the neighbors and then delivers it there so that the person can get the package later. But lately, what's been happening is that this is happening a lot because people may not be home. So at some point, I could store everything in my closet, but by now I need more room. So I built this shed in my garden to store all the packages of my neighbors. Now, I was pretty proud of that, so that's all fine. But at some point, whenever the neighbors of my neighbors got presents or got packages, the delivery person knew, oh, that person is at home. Let's deliver it there again. So I needed more storage for all these packages. And at some point, the whole street knew. So I needed to keep storing them in a lot of sheds. Now, because by now I have a lot of sheds in my garden, let's say I've n sheds, I need a smart way to store all these packages. Because I don't want to go look in every shed each time I need to get a package from someone. So the question is, how to store all the packages in these sheds? One way I could do it is to make a list of pairs of names and packages, and pairs of names and packages, and then put down in which shed I put it. But that's not really a great way because this list is growing larger and larger, and each time I have to go through the full list to find it. So that still takes n time. So the question is, how to do this smarter? How to do this in one time? How can I, when I know which person comes to get the package, how do I instantly know which shed it is? So the solution I have for this is I associate the sheds with numbers. And so I put numbers on the sheds. And what I then do is I ask for the house number of the person and put it in that shed. So that works really well, right? It's kind of like an array, and we know array retrieval is 01 if we just know the number. So that's very good. So this all worked. But then another problem happened. So what happened was, in more streets around my street, people were delivering packages to my house. And of course, then numbers would be used multiple times because there's multiple streets, of course. And also, what happened was that in more streets, the house number 1 exists than the house number 128, for example. So the shed of 1 became a lot more full than the shed of 128. So that was not really a good way to store it. So how can we do this then? So what we can do is we have to kind of find from a name, we have to kind of make a number out of that name, and then look in the shed of that number. That's basically what we're going to have to do. So calculate some integer from the information of that name, and then look in that shed. And this is called hashing. So we can do this in multiple ways. So what would be a good way? Say we have 26 sheds. How can we get an integer from a name? Or what hash function can we use? So one way to do this is we can take the first letter of the name and convert it to an integer. For example, the A is 0, the B is 1, the C is 2, etc. That would work with our 26 sheds because there's 26 letters in the alphabet. But the problem with this is if I do this, I took 10 random names from a random name generator and 3 of them ended up in the same shed. And a lot of letters are just not used that often in the English language. So some sheds become fuller than others, and that's not ideal. Because if we put multiple packages in the same shed, then we still have to search through the shed. So we want to divide it as evenly as possible. So another way to do this is we can take integers of all the letters in the name, and then sum them, and then at the end do modulus 26. So we get at least a number from 0 to 25. And that already works a lot better, right? All the names are in a different shed. Sometimes because they are close, the names are still put below each other. But each name is in a different shed now. So the two methods I showed you earlier are basically hash functions. That's what they're called. So the goal of these hash functions is to disperse the keys in as random way as possible. Usually what we do is we split this hash function into two components, namely the hash code and the compress. So what our hash function does was, well, it takes a key, the name in that case, and it converts it to an integer from 0 to n-1. So that's what our hash function does. But what we usually do is we split this in two. So first, we calculate an integer from the key. And in our example, that would be count all the integers from all the letters. So the R is, I think, 17, U is also something, B is 1, and Y is 24. And in total, that is 62. And then we compress this. So in this case, we do just a simple modulus of 26, and then we get 10. We do this because if, for example, we need to resize the amount of space we have, so suddenly we have 13 sheds, we can only change the compress. We can still keep the same hash code, but only vary the compress we use. And of course, since we have to try to disperse the keys in a random way, both of these functions, we try to do this. You can read about different ways to implement this hash code and this compress function in the book.